Okay, so is first of two presentations on object-oriented programming. Object-oriented programming is one of the common approaches of programming. There's generally two types of programming. Functional programming, where you write a function which uses variables so that you can calculate something, which is what we tend to do. But there's also another approach where you can actually model real world entities with their data and their behaviors, which is where object-oriented programming excels. So it allows us a way of modeling data and modeling real world entities. And in a nutshell, what is object-oriented programming? You could consider object-oriented programming to be something which looks like a house plan. If you want to build a house, then you go to an architect. Then he develops a house plan for you with where the swimming pools are going to be, where there's walkways, how many bedrooms or how many living rooms your house is going to have and stuff like that. This house plan is complete. What that means is that with that blueprint which you have, with that house plan, you can only build houses, as many as you want, of that particular type of the plan. Okay? So the house plan is the blueprint for creating houses like that. The houses you're creating are what we call the objects. The house plan with the house you have created determines how you're going to live in that house. Whether you're going to be swimming, if the house plan has a swimming pool, then you'll be swimming. If there's a slide, you're going to be sliding. If there's a mini football pitch, there's going to be that. If there's a living room, there's a dining room, you're going to be having lunch or dinner from your dining room because all these things have been put there. Are we clear? This is basically, in a nutshell, in the simplest way I can explain things. So if the house plan is a blueprint, the houses you're creating are the objects. If you wanted different types of house, you have to go and either you have to go and create that particular house from scratch. But sometimes people also want to maybe extend the house. You can make an extension of the house without the blueprint. You just make an illegal extension of the house. You add some more rooms so that you can have a chicken run and stuff like that. Or you go and make a completely new house plan. So either you can extend the house, which means that you can take your old house plan, you take it to an architect, then he makes extensions to that particular house. So then the new house plan is going to inherit certain properties of the old house plan. Okay? It will not look exactly the same, but certain things are going to be there. This process is what is called inheritance. And that is what you're going to look at next week. So for now, for this week, we want to look at how do we build this blueprint. Then after we build this blueprint, how do we create these instances of this house plan, which are called objects? In the process of creating objects from the house plan, from the plan, this is what is called instantiation. Then how do we access whatever it is we have to access in this particular case? The data and the behavior of whatever it is we're trying to do. And that's basically what object-oriented programming is. So the functional programming, we are interested in functions and their variables. When it comes to object-oriented programming, we are interested in the objects which are going to come out of this particular plan which we have, and what are their data and what kind of functions they are put together with. So an object is basically an instance of a class. So when you create a house, that house you have created is an instance of the house plan. It is basically a house number, this and this and this, and this other thing. The house itself, when it's created, maybe when the person creates the house, maybe it's going to have different colors, maybe to have different kind of windows, maybe the tiles which will be put will be different. So when the object is created, it has its own unique properties. Maybe the grass which is going to be put outside will be different. Maybe you use different kind of tiles. Maybe you use different kind of paint. You use different types of lights and stuff like that. So once we create an object, then we give it the data and all this behavior. That particular object, as much as we created it from the same house plan inside, it's going to assume a certain uniqueness. So our objects have got data, which are the variables. They also have functions which are going to work on this particular data, which are called methods or member functions. So basically, the objects we're going to create tend to be quite unique. They represent a particular state of whatever it is we're trying to model. So we use these so-called classes, these blueprints, to model real-world entities. Okay. So in this particular case, Python as a programming language, Python supports object-oriented programming, but Python is not a completely object-oriented programming. Python has got a mixture of functional programming. You can make your own functions in Python, but you can also do object-oriented programming. So you can make your functions, then if your function is useful, maybe you want to use it for whatever this thing we're trying to do, you can also create functions in this particular thing. So basically Python as a language which supports object-oriented programming, it supports object-oriented programming, but it's not completely object-oriented. It allows you also to do what is called functional programming. So a class, like we have said, a class is just a blueprint. You have to look at the class as a house plan. Then the houses you're going to create using that particular house plan, these are what we call the objects. The house you're going to create has got certain properties. The number of rooms, the number of how many kitchens do you have. Some people maybe want 2 kitchens. How many toilets do you have? How many sitting rooms and stuff like that. These are the data, and this data will inform how people are going to live in that particular house. So if you only have 1 toilet, you have to wait for someone. If there's a toilet is occupied, you have to wait. But you've got multiple toilets in the house, if this one is occupied, you can go to the other toilet. If there's multiple rooms in the house, if you're tired of sleeping in this room, you can go and sleep in the other room. That is behavior which is being informed by the design of the house. Exactly. The house plan determines how the people in the house are going to live, which are the operations you can carry out. If there's a slide, you can swim. If there's a swimming pool, you can slide this like that. And that's basically what we're trying to do here. An object is an instance of a class, and the process of creating objects is called instantiation. Another thing which you're going to introduce is something called a constructor. Now, most of us don't know how to build houses. So you want a house plan, you go to an architect, he draws a house plan for you. They tell you, this is how many materials you're going to need. But for you to build that actual house, you are not going to build it yourself. You have to engage some people to build the house. You have to engage a constructor. Whether it's a constructor this contractor guy comes he will come with his own builders. He will tell you what materials you need to buy, and as long as you pay the guy is going to continue building, and at the end of the day, you're going to have a house. So it turns out that the same idea also applies with Python. We need a function which is going to construct these objects for us, which is called a constructor function. And this constructor function, basically what it does is, when we give it the data and we define the functions, it's going to bundle together the data and the functions into one unit called an object. So that's what basically the job of the constructor is. It is to initialize your objects with data. So it gives your objects, this is the data you're supposed to work with, but on top of that, it also gives the object the functions which are supposed to work on that data. So when you create an object, it's like a small program with its own data and the functions which are supposed to work on that particular data. This is what is called the constructor is what is called an init. This is init for initialization. We have got 2. When you are writing this one function, you use 2 underscores in front, and 2 underscores after, like that. So what we're going to do here, we are going to create a what's this? A function, a class called a circle. We want to model circle objects, circles. We know that a circle has got a radius, and based on this radius, which is the only important piece of information, based on this radius, you can work out, you can carry out certain operations with the radius of a circle. For example, you can work out the area of a circle from the radius. You can also work out the circumference of the circle or the perimeter of the circle. So the data is the radius, and that's the only thing you need for a circle. As long as you know the radius, then you've got an idea of what kind of circle you have. Then what kind of operations can you carry out with this radius? You can work out the area of the circle. You can also work out the perimeter of the circle. These are the operations you can do with that. The other thing is that there is something called a pointer. And this pointer is denoted with this parameter called self. Now, within the house plan, we need something to refer to the house which is going to be created. A generic parameter we're going to use to be referring to the house which will be created, houses which will be created out of those particular house plans. And that's what the self is here. So the self here, parameter, points to the objects we're going to create. And using this self, we can carry out, we can reference it, we can refer to the data within that particular object using this self, and we can carry out operations using this particular self parameter. So the way it goes is that you start out by, you tell Python, I want to create a blueprint for this particular object. So you type class, like that. Then the name of the blueprint you want to create. This is what the circle is. So basically it's capitalized. You capitalize the first letter, so that's a circle. Then after that, you put in these empty parentheses. For at this particular point, we are starting from scratch, so we're not going to provide any information there. Then you end with a colon here. So this is basically the definition of what we're trying to do. We're telling Python we want to create a blueprint. This is the name of the blueprint. We want to create a blueprint for creating circles. Then next, we have this text which you have here in quotation marks. This is what is called the documentation. This is the doc screen. This is a description of what this particular class does. So basically it says a blueprint for creating circle objects. After that, the next thing we're going to do is we're going to define this so-called constructor, which is a function we're going to use to automatically construct these circles. So what is the constructor going to do? The constructor is a function. So we start out by def. Then here, if I do that, you see that there's 2 underscores there. So you start out by typing in 2 underscores, then init, which is short for initialization, and after that, there is another 2 underscores like that. So you start off the def, then init, 2 double underscores, init, then double underscores, then after that, the first parameter is this self. This self parameter is referring to the objects you will create. Okay. So the self parameter needs to be the first one. Then after that, any other parameters we are interested in. In this particular case, because we are interested in circles, the other parameters we are interested in is only the radius. The only information we will have to provide will be the radius. This self will automatically be referred to because of the name of the blueprint, the class we're creating there. Then we end. So
why is it that you do the 2 underscores first?
That's how the...
Oh, that's the format.
Yes, that's a convention which is used, yes. Then we have, again, in our function, the same thing similar to that, a description of what this particular function is supposed to do. So it initializes circle attributes. It initializes circle attribute to radius. So the radius we're going to give as we are constructing this particular object, we have to provide the value of radius. It will be this one. This value of radius will be obtained, we'll get it, then it will be connected to the radius of the circle. The self refers to the circle we're going to create, then we'll make a match between the radius of the circle we're creating and the value of radius you have provided. So this bit here, self.radius, refers to the radius of the circle we're creating, then we're providing a value of radius. So the value of radius we're providing is going to be stored in the value of the object you're going to create. So basically, that's how initialization is done. Then next, we create another function. This function, these are called methods now. These don't do initialization, they do other things. For example, this one is just going to give us the radius, get radius. For us to get the radius, we are assuming now that this particular object has already been created. Therefore, we just have self here. Show that we are referring to a particular object. This self is pointing to the object which has already been created. So how are we going to obtain the radius? We're just going to say return self.radius. The radius of give us the radius of this particular object you have been connected to, like that. So self.radius. If you want to update the radius, in this particular case, we can also update the radius of the circle. If you want to update the radius, we have to provide a new value of radius. So we have to refer to the object, the circle. So that's what the self is doing there. Then we need to provide a new value of radius if we're going to update the radius. Now, this new value of radius, if we are going to make an update, we should make sure that the radius is not 0, it's not negative, it has to be greater than 0. So we make a check here. If new radius is greater than 0, then we reassign new radius to become the radius which is self.radius here. So this is how we're going to update the radius of an object, a circle object which you have already created. Otherwise, if the radius is negative or it's 0, we'll print out the message say radius must be positive and non-zero. If we want to increment the radius, using this function increment radius, we'll have to refer to the object which has already been created, because you can't increment the radius of a circle which has already been created. So this circle must have already been created. So we are referring to that. Then how much do you want to increment the radius? So in this particular case, if that's the case, if the increment to be done, then we'll say the radius of the circle, self.radius, the radius of the circle, self.radius, plus the increment. Then we should save this back to self.radius. So this way we are going to increment the radius. We'll refer to the actual radius, then plus we add something, then we save it back. And it works quite fine. It might look confusing right now, but if we start doing what you're doing with the explanation I'm offering, then it will become quite clear. If you want to get the area, you don't have to provide anything. The only thing you have to say is that we'll need an object which has already been created, which is what the self is doing here. We'll need an object which has already been created, which already has a value of radius. So in that particular case, for us to get the area, we'll need a value of pi, because for us to work out area, we need pi. So we set pi to 3.14, then we calculate area. Area is going to be pi times the radius of the circle. But for us to get the radius of the circle, we need to refer to the circle. And how do we refer to the circle? By using self. So the self is the one which is pointing to these particular objects we have created, or these particular objects which will be created. So self.radius, then we square that to the power 2, then we calculate the area, then we return the area. Similarly, if you want to work out the perimeter or the circumference, we need a value of pi. Then we work out perimeter is going to be equal to 2 times pi, then self.radius, then work out the perimeter. So with this, if we run this particular code, fine. Then if we ask to check if this particular blueprint, which we say if we do this, we're going to create this particular blueprint, if it has worked, then we ask help. So we give the name of the blueprint to help, and when we do that, this is what we get. It says help on class circle in module main. And what does a class basically have here? So basically here it says class circle objects. then how do you use the class in this particular case? How do you construct things? You type circle, then you give it a value of radius. So it only takes a value of radius. There is also the self there, but the self refers to what you're going to create. So you don't provide self per se, you only provide the parameter radius. Then the functions or the methods defined here, there's this one, the init here. This init is the constructor, which is going to help us automatically construct the circles. Then the description initializes the circle attribute radius. How the thing is being done, that implementation part is not being shown. You have to go and check with the person who created the plan and how they did that. Next, there's get area. Now things tend to be arranged in terms of alphabetical things. So the way we created our functions and the way they get displayed here, they get displayed alphabetically. So there's area here, self, get area. So you don't provide anything, it's just a self. Then it's to give you the area of a circle. Get perimeter, you don't provide anything. It will calculate the perimeter of the circle. Get radius, you don't provide anything. It will give you the radius of a circle here. Increment radius, so here there is self, then there is an increment here, so you need to provide the increment value. Then update radius, self, new radius, update the radius of a circle, and a bunch of other things like that. So, according to Python, we have created a blueprint for creating circle objects. Now, how are we going to create the circle objects? For us to create the circle objects, of course, if you're going to create a house, it will need a house number or something like that. So basically, this particular bit here, the circle one is the variable which is going to store this particular circle thing you're going to create. So the way you do that is you write out the name of the class from which you're going to create these particular things. Then you provide a value of radius. So the value of radius we are providing here is 5.5. So we want to create a circle with a radius of 5.5. Then we're going to store it in this particular variable, circle one. So if we do that, then this one here, this one checks, this is a function, is instance. An instance is an object. So it checks if the object you have created is of a particular class. So here we are checking that the object circle one is the object circle one of class circle. If we have successfully done the creation of this particular circle one, then the result should be true. Otherwise, it should be false. So in this particular case, when you run this particular function, it gives us an answer. When you print out the answer, it tells us that yes, circle one is of type circle. So we have created, through this particular process, we have modeled a circle which we didn't have. But for us to model this circle, we needed a blueprint. A blueprint which had data, which is the radius, which also had functions, which is the get area, increment area, update area, the get perimeter, and stuff like that. So we have a radius value, and we have created something which has got a radius value, and we have put this radius value together with the functions which are supposed to operate on this value of radius. So we have created a unit, like an atom, with everything, with all the things it needs for it to do is the things it needs to do. So how do we access the attributes or the data which a particular object has? The first thing we're going to do is, first of all, you can check if a particular object has a particular attribute or it has a particular data. So in this particular case, you can use a function called has attribute. This is has, English has. Then the other thing which follows is attribute, which is short for this particular word attribute here. So here we are checking if the object we have created, which is a circle one, whether it has got the attribute radius. So this is a true or false kind of situation here. If the attribute is there, then we get a true. If it's not there, then we get a false. So if we run this particular function, has attribute on circle and radius, then we print out the answer, we get a true, that indeed the circle thing has got attribute that. Then next, how can we get this particular, if the attribute is there, how can we get the value corresponding to this particular attribute, you can use another function called get attribute. This is get for attribute. So you provide the name of the cycle, then the name of the attribute you want to get. So in this particular case, it's no longer a true or false thing, but you're going to get the value of the radius, and that value of the radius is going to be stored in answer. So if you do that, then you print out answer, you get the attribute, which is 5.5. So this gives you access to the radius attribute of this particular thing. There is an even much more simpler way to do things. Basically, you say print, you say cycle dot radius. If you know that this particular attribute is there, they just type the name of the cycle, then you put a dot, then the radius. This gives you access to that particular thing, then you get your 5.5. So these are the two ways. First has attribute. It allows you to check if this particular data is in this particular object. So if the confirmation is there, that's fine. Then you can get it in two ways. Either you can use get attribute, or you can say the name of the cycle, then you put a dot, then you print radius, then that gives you 5.5. However, you can also decide to say, okay, fine. You create another object, cycle 2, with a radius of 10. So this particular object is being created as a result of the blueprint. But now, because you don't want to go to the architect so that he can make you a normal extension, and you don't want to let the city council know that you've made an illegal extension to your house, you decide to add another room. Illegal. Which is not advisable, but people do that. So this time around, we're going to say, fine, let's access the radius of the cycle which I've created. This is the radius of the cycle. Now we're going to say, okay, we want to add something. A small extension only to this particular house. The other houses we're making as a result of this plan, then one of these houses we're saying, we want to add a chicken run next to the house. You know? You want to add a small illegal extension. So you add a new you are adding a new property which was not there. So in this particular case, now that you have created radius 2, this cycle 2, which has got radius 10, now we want to add a new property, a new attribute. We want to add color, and the value of the color of this cycle should be blue. Only this particular. We want to make a small illegal extension which the council doesn't know about, and because we don't want to spend money, we don't want to go to the architect so that he can make a proper extension with this new extension. So when you do this, this is the attribute you're adding only to cycle 2. Okay. This attribute is being added, set attribute is being added only to cycle 2, and the color is going to be blue. So when you do that, then you print out cycle 2 with color, then it gives you blue like that. So we kind of made some illegal extension, which is not something I encourage, but it can always be done for a particular object if that's what you want. How do we access the functions which are supposed to operate on this data? We have a number of functions. Even those functions, we access them using the so-called dot notation. In this particular case, you type out the name of the object, which is this what you have here, cycle 1, then you put a dot, then followed by the name of the function like this. For example, get radius. So you say cycle 1 dot get radius. Whatever the radius is, it's going to be got, then it needs to be stored in answer like that. Then if you print out answer, it gives you a radius of 5.5. Here, get area. So we say cycle 1 dot get area. So this particular case, this is going to, using the radius, it's going to carry out an operation of working out the area. Then we print out the area, which has been worked out. So the area is going to be 94 point that. You can also work out the perimeter, get perimeter. You do that, then you print out the perimeter, which is going to be that. So the things we have there, they actually do work. And basically, we have created these small things with their data in the functions we're supposed to work on them. We can modify these attributes, the data, we can modify it. For example, if we print out the radius of the cycle 1, the radius of cycle 1 is 5.5. I can change the radius of cycle 1 from 5.5 to 7.5 this way. So I type cycle 1 dot radius, then I give the value I want the radius to be this time around. So I do that like that. Then I print out the radius of circle 1. Now the radius of circle 1 becomes 7.5. Now if I, using this new radius, I can work out a new area like that, which would be that. They can also work out a new perimeter, which is that. The only thing, the second one was already there. The only thing I modified was the radius. I can do that. I can do it that way, directly. I can also modify using, so I print out circle 2. Circle 2 is 10. I can modify using, if there is a function which has been created like this one, update radius. So circle 2 has got radius 10. I can update the radius of circle 2 to 15.5. So if I do that, I run that, then I print out the radius for circle 2. Now it's 15.5 from 10. Then I can also get the area for circle 2, which will be, and I print it out, which is that. And I can also get the perimeter with this updated value, which is that. Then I can also make increments. I can make increments to the radius using those functions I put up there, the one for increment. So in this particular case, I print out circle 2. I think the radius is too much. Let's reduce the radius by 7.5. So I put minus 7.5 as the increment thing. If I want to increase the radius, I'll put a positive value. If I want to decrease the radius, I put a negative value. So if I do that, when I want to increment the radius by minus 7.5, now when I print out the radius of circle 2, I find that the radius is now 8. So it has been reduced from 15.5 minus 7.5, it's now 8. Then using this new radius, I'm like, okay, fine, 8 is not good. Let me increase the radius of circle 2 by 2. So from 8, I want to add 2 to the radius of circle 2. So I do that. Then now when I print out the radius, now the radius is 10. So it's behaving exactly the way we expect it to behave. Is this clear? So you simply need to understand how the blueprint is made. Once you understand how the blueprint is made, everything down here is straightforward. Okay. Last but not least, when you create these blueprints, these classes, you can, because you don't want to you want to create a class, then if your blueprint is nice, it does the job you want it to do, you want to store it somewhere. So once you create a class, you can actually store a class in a file. Okay? So in that file you're going to store a class, that is what is called a module. So you can create a module. So a module, we have seen before, modules, in modules, we can create a module which stores functions. You've got a bunch of functions. You've created functions, then you store them in a file. What you're doing there is functional programming. Your concern is creating functions, what kind of values or variables do these functions receive, parameters, and how do they operate on this particular things. In this other case, the same modules, you can also store blueprints of creating objects. The difference here is that when you're talking about an object, there is a data, which are the variables and the functions. This blueprint is going to combine your data and your functions together into one basic unit called an object. When you just have a function, the data is separate, the functions are separate. So you're dealing with two separate things which are not connected, and you have to connect them yourselves. Are we clear? So in this particular case, apart from the circle, I have on this computer a module called shapes.py, which contains a blueprint for creating a circle, which you have done. It contains also a blueprint for creating squares and also triangle objects. And I'm going to open that particular thing so that you can see how it looks like. So somewhere on this computer, there is a file called shapes, this one, shapes.py. So I click on this particular file and I open it. When I open it, the name of the file is shapes.py. How does the file look like? It starts with this triple quotes. This is the description of what the module does. What is the module doing? So in this case, we're saying this module contains templates for classes circle, square, and triangle. And what are those templates? This one we have already seen the class. We discussed this one at length, and this is basically what I've just put here. So if I wanted to give this particular file to someone, I can give them this particular file, and based on this particular file, they can start creating their own circle objects. The other thing I've created is this particular template for creating squares. So if I want to model squares, the only thing I will need a constructor for the square, and the only parameter I need for create a square is the length. Then after that, if I have a length, I'll initialize like this, self.length, I initialize the length. Then what can I do with what kind of functions can I operate on a square? I can get the length of the square, I can get the area of the square, I can also get the perimeter of the square. I can do that. These are operations I can carry out. Then also for a triangle, what can I do? So I need a constructor, but for me to create a triangle, I need two things. One, I need to know the base of the triangle. I also need to know how high the triangle is. So these are the things I need. So using this, I initialize the base, self.base, to whatever value of the base I'm going to provide. I also initialize the height of the triangle I'm going to create to whatever value of height I'm going to provide. Then based on this, I can get the base of the triangle, return self.base. I can get the height of the triangle, self.height. Then I can also work out the area of the triangle. The area of the triangle, area is going to be 0.5 half times the base of the triangle. The triangle itself I'm referring to using this through the self, then times self.height, which is the height of the triangle. Then I calculate the area, then I'll return that particular area. So fine, that is set. Then we go back to this particular thing. Because that thing is in a file or the module, I can import these two classes from that particular. I don't have to import the second one. We have already seen what the second does, but I can import these two classes. So I'll say from shapes, import square and triangle. So I run this particular command. Then now that it's not complaining, what I can display help for square. So if I say help square, what do I get? This is what I get. Square, triangle, what does it need? I only need to provide the length. Then what kind of methods? There is the constructor here, there is get area, there is get length, then there is get perimeter there. So in this particular case, I was like, fine, I want to create a square one, and square one must have a length of 3. So this is the name of the template and the length which I provide like that. Then I want to access the length of square one. It's going to be 3. I want to get the area of square one. It's going to be, I print that. It's going to be 9. What is that? Something is not correct. Area is supposed to be. Okay, yes. Then square. Yeah, square. Yeah, fine. Then for triangle, if I do that, this is a description of what the group length looks like. If I want to create a triangle, I'll say triangle. I'll set the base to 6. I'll set the height to 4. Then triangle 1, like that. Then I print out the base 6. I print out the height 4. I want to work out the area of the triangle. Get area. Then I print out the area. That's what you have. You have 12. So basically, this, in a nutshell, is an introduction to object-oriented programming. How do you model your own real-world entities? If you have got an entity which has got data, then that data, there are operations you can carry out on that particular data, then you're good to go. You do object-oriented programming. You just need to identify the data you need. Then, after you identify the data you need a constructor. Then after that, what kind of operations can you carry out on this particular data? What kind of calculations? And once that's done, then you can build your class. Then using this class, you can do whatever it is you want to do. Okay, so that's the first part of our talk, and it ends here.
Thank you very much, Mr. Sichone. Do we have questions? We have about 8 minutes to 11.
Understandably, first time you see this, it's a confusing way of programming. But this is the actual reality in which we live in. We have objects with data, For example, you've got your bank account. Your bank account has got your name, you've got the account number, the bank you host it with, there is the money you have. There are certain things you can do with the money. You can withdraw it, you can deposit, you can get a loan, use it on your account. Loan and your bank account are different things. You've got a loan account, loan, and something else is happening. So your loan can interact with your bank account. The loan will be subtracting every month. The loan will be getting money from your thing like that. So there is different things you can do. You've got your mobile money account. You have got you as a student. You have your own name. You've got your own details. You're taking certain courses. You have certain marks in a particular course. All these are things you can model. So the limit is up to your imagination. What is it you actually want to model? Translate from the physical world into the computer. You can't model everything. You only have to focus on the most important things and the most important behaviors. Then you can do this. It will naturally come with time. Then you, yeah.
So, Mr. Karewe, did you have a question?
Yeah, maybe things will come in future. You also have an option for running, for example, in mind, only radiation is passing through certain thicknesses, say aluminum. You can actually pile, increase the thickness of the aluminum, and then find out how much intensity of the radiation goes through using the law of exponential.
So in this in that particular case,
In which case you'll be saying, suppose the thickness is 0.1 millimeter. You do the calculation.
yes.
0.15. And then at the end of the day.
So basically, you'll be modeling what's it called? A shielding.
Yeah, yes,
You'll
yes,
be
yes.
modeling a
Yeah.
shield. So you have to identify
Yeah.
which material is it you are
Yeah.
trying to. If you say you're building a shielding thing, what properties does it have?
Yes, exactly.
There's things like thickness. What is the material itself? The name of the material, maybe it's aluminium or it's lead. What is the density of this particular material? Then maybe these are things then you need to work out, and maybe if sometimes
Maybe when
the
it comes to
amount of incident radiation which is going to fall into this on this particular material, and based on these particular things, the incident radiation, the nature of the material, then the thickness of the material. So these are the what's this? Your data points. Then you carry out an operation.
Yeah, exactly.
The operation you're going to carry out, that is the method. That's a function you're going to, based on this modeling. So you can model
So you
a
can
shielding.
actually have a counter running.
The limit is up to you. The limit is up to you.
Yeah.
You can increase, basically we are saying, you can increase the thickness of the block. You can increment the thickness of the block. You can reduce the thickness of the block.
Yes.
These are operations you can carry out. Or you can increase the density of the block. These are things you can all do. You can update the density so that you see what's happening. You can increase the thickness so that you see what's happening. And these are all things.
Present the results in the form of a table.
Yeah, these are all things you can do.
Even a picture, you can integrate this, I think, with other data visualization tools.
You can even model these things. Things like, for example, Cartesian points. You've got your x and y. You have your x and y, and from that x and y, maybe you want to know what's the point from the origin, or between your multiple points, the distance between these points in 3D space, or whatever it is. You can do that. You create a template which is going to give you these points. Okay, you fractions, or for example, Python comes with complex numbers already built in. But how did they do that? It didn't have complex numbers, but they had to build that ability based on the behavior of complex numbers. If you're going to build a complex number, then how does a complex number work? How do you do addition? How do you division? How do you do multiplication and all these things like that? You can fractions. We don't have fractions per se, but you can build things like fractions. We know by hand how to add fractions, how to subtract, how to do multiplication, how to do all these things. These are things you can build in. So the limit is basically up to you.
Any more questions or comments?
Okay,
So for me, maybe something I've observed or I have heard is that this Python can do both object-oriented programming as well as functional. I'm not very sure, maybe Mr. Sichone or Combezant, Java is good in object-oriented programming. I don't know among the two, Java and Python, which one you think can better handle the operations of both object and functional programming?
I don't have a lot of experience. I don't have experience with Java. But from the talk from the people I know from computer science, Java is a bit difficult compared to what you have done. The things you have done here, if they were to be done in Java, it would be a bit more complicated. They can be done, yes, but they are not as simple as what you have done.
So maybe just to add, our colleagues in computer science here use Java programming language. If they have started using Python, maybe they use it just a bit.
They use Python also, but just a bit for other things.
Okay.
Yes.
But I think maybe in some of these C programming languages, you have to do the functions yourself.
Even
For
here,
example, in this one, you just say area.
Yeah.
but we
It
created
knows how to
we
calculate
created the area here. We already gave it the here.
the pi, yeah, you have that.
We already gave it how to calculate the area.
Oh, okay, yeah.
So the how to calculate the area in everything has been put together. The radius packaged together. It's like it has got a bug. Part of the bug is the what's this? The radius. The other half of the bug are the functions it needs to operate.
Yeah, so just maybe finishing up, our colleagues in computer science like using Java. Here at UNZA, I don't know what they do in other institutions, but yeah, Python is a much simpler language. Ourselves, we have been using C++ here, Fortran here just to do functional programming. If you are to do object-oriented programming in C++, it's very hard. Initially, they started with C. C was more like pure functional, but they added the plus to introduce this object-oriented. However, we have learned now that this Python offers much simpler ways of doing things. So the earlier we get the full grasp of it, the better for us, because we can do many things. We can even link it to web design, right?
Yes.
Website design.
Yes. Python is just more flexible as compared to Java.
Yeah.
Because with Python, you can do, as we speak now, we can do everything, starting from web to Python for scientists. You can do in all scopes, from web designing and the calculations of the function. And
Sure.
talking about Java,
We're almost done, don't we?
with the Python, you can import. You
We're
can
ending.
import
We're ending.
JavaScripts into Python.
Okay.
Yes.
Okay, so I think